All right. Hi, algebra students. It is just me in the classroom today, so I'm talking to you all at home. The lesson we're looking at today is more on our systems of equations that we've been looking at. Today we're going to introduce the third method you can use to solve them, which is called elimination. So, like we said, we're going to be looking at systems of equations and specifically how you solve systems of equations using this new method here. This is actually a two-part lesson, so we're going to start learning this method today and then look at some more examples tomorrow to finish up the lesson. To start us off, I want to quickly review everything we've learned about solving systems so far. I've mentioned earlier there's three different ways you can use to solve systems of equations. The first way we learned is graphing. If I'm going to ask you to solve something by graphing, it means I'm going to need to give you a graph. And when you're solving by graphing, you're going to be graphing both of those equations from the system on a single coordinate plane or single graph and looking for that intersection point. The intersection point would then be your solution point. The second way, the way we learned yesterday, is substitution. To substitute something means to replace something with something else. So in substitution, you would have your two equations. You would use one equation to substitute into the other equation. Now, to use substitution, all of the systems we had yesterday, what they had in common is they all had x equals something or y equals something. We would need to know what one of those variables equals in order to substitute it into the other equation. The last way, and my personal favorite way, is using elimination. Elimination involves what the word sounds like. It involves eliminating something in order to solve your system. So to give you our first example using the elimination method, we are going to look at this system of equations right here. Now, if I tried solving it using one of the other ways, I could solve it by graphing, but I would need to get some graph paper. I would also need to change both of these equations into slope-intercept form. I would have to change both of them to look like y equals mx plus b. So there's a lot of work involved in that. In order to use substitution, we said a moment ago I need x equal to something or y equal to something. Now, I don't have that yet. I could get that. I could solve for one of the variables and use that. But this right here is a perfect example of what a system could look like where elimination is ideal. Elimination is going to involve you eliminating one of your variables, either eliminating the x's or eliminating the y's. And the way you do that is by combining the two equations. I'm going to start off, take a break on this system and look at another system. The system I'm going to look, though, has numbers. So I'm going to pick any two equations with numbers, maybe 3 plus 3. One thing you can do with any equation is you can add two equations together to get a new equation. So notice if I add those two equations together, 1 plus 2 does equal 3, 3 plus 3 does equal 6. So they're both true equations. And when you add two equations together, 1 plus 3 gives you 4. 2 plus 3 gives you 5. 3 plus 6 gives you 9. When you add two equations together like that, you get another equation that also is true. It says something different, but it's still true. That's the same idea we're going to do here with our elimination method. I have two equations right now. I am able to add those equations together to get another different equation that is also true. When I go to add these equations together here, something unique is going to happen. When I go to add those equations together, the first thing I'm doing is taking x minus x, or x plus negative x. What does that equal? What is x minus x? X minus x is 0. It's nothing. It cancels, or here we could say it eliminates. That right there is going to be the goal of the elimination method. Combining your two equations in a way so that a variable eliminates. Now, if I keep going, if I add the rest of it together, y plus 2y gives me 3y, and 5 plus 4 gives me 9. Now the reason we want something to eliminate is when you have one variable eliminate, it gives you an equation with only one variable left. And now we've got an equation we can solve. If 3y equals 9, I can solve that by dividing both sides by 3, which would leave me with y equals 3. If I had an equation that still had x and y in it, I wouldn't be able to solve for one of my variables. But when a variable eliminates like that, you can solve for the other variable. Now, using what we learned yesterday and what we learned before yesterday, we know that when you're talking about solutions to systems, your answer looks like a point or a coordinate. Your answer is going to have an x coordinate and a y coordinate. At this point, I figured out y. I figured out that y equals 3. So I know for my solution point, there's going to be a 3 there. But I still need an x coordinate. Now the rest of this is going to be very similar to what you did yesterday. Do you remember what we need to do? Well, I already know half my answer. I know y equals 3. So I can figure out x by taking what I do know and substituting it into an equation and then solving for x. Now we saw yesterday that it does not matter which equation you use. I can substitute 3 here or I can substitute 3 here. Both of them should give you the same answer for x. What I recommended yesterday is pick the equation that looks like it would be easier for you to solve. For me personally, I think this first one right here looks like it would be pretty easy, so I'm going to use that. Instead of saying x plus y equals 5, I'm going to say x plus 3 equals 5, and then I'm going to solve for x. When I go to solve for x, I need to get rid of my plus 3 with a minus 3, and that will leave me with x equals 2. Now I've got everything I need to know to write my solution point. I can say my x coordinate is 2, my y coordinate is 3, so the solution to the system is 2, 3. Just like when we were solving by graphing and solving by substitution, we don't have to stop here. You can still check this answer just like you checked with those other methods. Do you remember what we did? You can check by substituting this point into your system. So if I wanted to check my answer, I could check by substituting both the 2 and the 3 for x and y in both of the equations. So for this first one, if I do that, it would say 2 plus 3 equals 5, which is true. 2 plus 3 does equal 5. For the second one, it says negative x, so that would be negative 2 plus 2 times y, so it would say 2 times 3 equals 4. Might have to do a little math for this one to see. We've got negative 2 plus 2 times 3 is 6 equals 4. And let's see, negative 2 plus 6, that does equal 4. So that one's also correct. That lets me know that I have indeed found the correct solution point. There's only one point that when you substitute, both of those equations are true, and we figured out that one point. Now, if I were to take my point and substitute it into both equations and one of them's not true, one of them doesn't work out, like maybe this one says negative 2 plus 6 equals 100, that would tell me, as the student, there's something wrong with my answer. It should work for both, but it's not working for both. I could go back and see if I could find the mistake in my math. So this was my example. I've got one more. I was going to have the student in the class today come up and do this one, but since he is not here, maybe you want to pause the video, try this one first, and then resume the video to see if it's correct. Alternatively, if you're like, whoa, what is she doing? You can go ahead and just watch me do it, because there's going to be one more for you to try. All right, maybe you've got an answer. Maybe you just stuck around to see me do another example. For this one here, remember our goal is to get a variable to eliminate. So I noticed that if I add these two equations together, 9x plus 2x isn't going to eliminate. That's going to give me 11x. But 2y minus 2y, that'll give me 0. So the y's this time are going to eliminate. And then that last one, 14 minus 36, You want to be a little careful with that one. It might help actually to flip them around if you're doing it by hand to see that you're getting 22. And since that larger number is negative, it should be a negative 22. I've got my equation 11x equals negative 22. To finish solving, I want to divide both sides by 11, and I get x equals negative 2. Now, I hope you didn't stop there. That's only half of our answer. X is negative 2. Well, what about y? In order to figure out y, we're going to take our x and substitute it into one of these equations. Doesn't matter which one you picked. Maybe you picked the first one, maybe you picked the second one. I'm going to choose this first one. So if you chose that one, follow along. If you did not choose that one, you should see that I'm going to get the same answer as you. So if I do this one, I'm going to have 9 times my x, which is negative 2, plus 2y equals 14. 9 times negative 2 is negative 18, plus 2y equals 14. To get rid of my constant, I'm going to add 18 on both sides. That's going to give me 2y equals 32. And then my last step, I'm going to divide by 2 on both sides. That's going to give me y equals 16. So I get negative 2, 16. Well, I can still finish this up by checking my answer. I'm just dancing all over the board. We're going to come over here on this side to check my answer. To check, I'm going to substitute both of these numbers into an equation to make sure it's true. Ideally, I should do both. Because of time, I'm just going to check the second one here. So if I wanted to check 2 times my x, which is negative 2, minus 2 times my y, which is 16, should equal negative 36. When I go to do that multiplication, I get negative 4, and minus 32 equals negative 36, which is correct. So that helps me feel more confident in my answer. Like I said, there's one more similar to this. So if you have not tried one on your own yet, I would make this one the one you try on your own. The last one here looks like this. All right, when you go to do this one, you're going to see that if you add those equations together, your x's cancel out and you're left with 5y equals 20. When you solve that equation, you get y equals 4. When you substitute it back into one of the original equations here, if you're doing the first one, it would look like this. And when you go to solve that equation, you get x equals 4. So we're left with the solution point for 4. Don't forget to put those two numbers together and write it as a single point, because that's what your final answer would look like. And if you check that, you're going to see that it's correct. Now, as we were going through these, maybe you're at home wondering, well, every single time she's adding those equations and something cancels out, something eliminates. Is that always going to be the case? And if you're wondering that, I congratulate you, because the answer is no, that's not always going to happen. So the rest of the examples we're going to be looking at addresses what you do if something just doesn't immediately eliminate. So the first one we're going to look at looks like this right here. Now, if I was treating this system of equations like all the other systems we just did, if I went to try adding them together, 6x plus x gives me 7x. And 6y plus 6y gives me 12y. I'm not going to write anything down because I'm already seeing nothing's eliminating. And remember, the whole purpose of elimination is that one of the variables eliminates. If we were, I will write it down for a second. If we were to add those together, notice you're getting an equation that still has two variables in it, and you can't solve for one of the variables. I mean, you could, but you're not going to get x equals a number or y equals a number. Because this one's a little different, our strategy to get them to eliminate is a little different. When you're thinking about things that eliminate, in the last problems, they all had something in common. Each time, for it to eliminate, it had to be the same number with different signs. A 2 and a negative 2 gives me 0. Before that, Oh, here it is again. A 2 and a negative 2 gives me 0. Before that, a 1 and a negative 1 gives me 0. You notice there's a theme here. So in this one we're looking at here, you might have looked at it and originally thought something was going to eliminate, because if I look at the y's, we're really close to them eliminating. It's just instead of them both being positive, I would need one to be negative. A different strategy you can use to get variables to eliminate in your system is instead of adding both of the equations together, we could subtract the second equation. Now when you do this, this goes back to what we had seen in Algebra 1A with subtracting polynomials. If I'm subtracting this, I'm subtracting everything. So you can think of it as having parentheses around there. You could also think of it as kind of like distributing a negative 1. Either way, if I want to subtract this equation from this equation, you can do it all at once if you want, but I think it actually helps if we rewrite it. I'm going to keep that first equation the same. And if I want to subtract this equation, what that means is I'm going to be subtracting the x. I'm going to be subtracting the 6y. And when it comes to that 5, I'm subtracting a negative 5. Well, a negative times a negative gives me a positive 5. Once I've done that, now I'll go through the same process I did before and go by each term. So for this first column, I've got 6x minus x. That would give me 5x. For my y's, I've got 6y minus 6y. That gives me 0. Those eliminate. That's what we were trying to do. And then on the other side of my equation, I've got 0 plus 5, which would give me 5. From here to the end, now it's the same process we did for those first couple. I've got an equation with only one variable, so I can finish solving for x by dividing by 5. That would give me x equals 1. And then just like those others, my answer is going to be a point that has an x and a y. We figured out x is 1. I still need to figure out what y is. Now the difference here is I've got the two original equations, and I've also got this equation here after we distributed that minus sign through it. You can use any of the equations. You could use this one, or this one. I always recommend using one of the original equations though. We could have made a mistake when we went to distribute that negative sign, which is why I think it's good to start with the original ones. So I've got x equals 1. We're going to substitute that into one of the original equations, just like before. It doesn't matter which one you use. I'm going to use this first one. So we've got 6x plus 6y equals 0. When I substitute x equals 1, it's going to say 6 times 1 plus 6y equals 0. 6 times 1 is just 6. So we get 6 plus 6y equals 0. To get y by itself, I first need to get rid of that constant, that 6 there. That would leave me with 6y equals negative 6. And then I can finish by dividing both sides by 6. And I get y equals negative 1. So my final answer is the point 1, negative 1. So one other strategy we can use, if nothing eliminates when you add, another strategy you can use is you can subtract an equation. You can think of it as subtracting, or you can think of it as multiplying by that negative 1 there. They really mean the same thing. Subtracting an equation is the same thing as multiplying through that equation with the negative 1. So now that you've seen this, I've got another one for you to try. And you will try it as soon as I erase this board. For this one here, we've got the equations x plus 7y equals negative 5 and x minus y equals 3. Go ahead and try that one now. All right. So similarly to that last problem, I noticed that if I were to add those equations together, nothing would eliminate. X plus x gives me 2x, 7y minus y gives me 6y, nothing's canceling out. However, if we were to subtract, if I were to subtract that second equation there, that would give me a negative x. Negative times negative gives me positive y, and then equals negative 3. If I use that equation with this first equation, then I see those x's would eliminate. They would cancel out. So if we do that, we would have no x's left in our equation. We would have 8y equals negative 8. And then when I solve, I divide both sides by 8, and I get y equals negative 1. That would be the first part of my answer. The second part, I'm going to substitute this. I think I'm going to substitute it into the second equation this time. It would say x minus y. Well, y is negative 1, so you want to be real careful with those signs. I need minus negative 1. I need minus negative 1, which is the same thing as x plus 1. So we get x plus 1 equals 3. That's a little messy, I'm sorry. X plus 1 equals 3. I can subtract 1 on both sides, and that gives me x equals 2. And that would be our answer there. Now that is one strategy to do this. There is another strategy you could have used. So if you did something different but you got the same answer, you might already have an idea what this last example we're going to look at today is. So the last example looks like this. Now if I look at these two equations, if I tried the first thing we were doing, which is adding those equations together, I see nothing's going to eliminate. 16 minus 8 doesn't eliminate. Negative 10 minus 6 doesn't eliminate. I also noticed that if I tried subtracting, still there's nothing that's going to eliminate. So what I want to do is go back to what we said about elimination. In order for a variable to eliminate, what needs to be true about the signs? The signs need to be different. You need a positive and a negative. So we need those signs to be different. That was the reason why we are subtracting in those last ones, is because if you have a 6y and a 6y, that's not going to eliminate. But if you change one of the signs so that they're different, you change one of those signs by subtracting, then they can eliminate. But what was the other thing we said needed it to be true? You need the signs to be different, and you need those numbers to be the same. So I would need a 6y, for example, and a negative 6y. I need the signs to be different. I need a positive and a negative, but I need both of them to be 6's. So keeping that in mind, if I jump back to that last example, here, nothing's going to eliminate because both times those numbers aren't the same. Here the signs are different, but the numbers aren't the same. Here the signs aren't different and the numbers aren't the same, so there's really a lot we would need to change there. I'm going to have you pause the video, see if you can figure out what we would need to do here. Did you figure it out? Well, we've been saying we need these numbers to be the same. In order to make that happen, we can multiply an entire equation by a number. I'm going to do one of those little silly examples again with numbers real quick. If you have an equation, you can multiply that entire equation by a number and get another equation that's true. So for example, I could multiply this equation by, I'll choose a random number, 2. It would give me 2 plus 4 equals 6. That's also true. It means you can multiply equations by numbers to make it work in your favor. So for this system here, I noticed that right now these are different signs. That's good. We want them to be different signs. But I noticed these numbers are not the same. I need them to be the same so that something eliminates. Do you see which equation we could multiply and by what number to make them the same? Well, I know that if I multiplied 8 by 2, it would give me 16. That helps me know that if I were to multiply this entire equation by 2, that would give me the number here that I need to make something eliminate. If I were to do that, I'm going to put my answer over here. 2 times negative 8 gives me negative 16x. Don't forget though, you have to multiply the entire equation. So we did that. 2 times the negative 6 gives me negative 12y. And then the last part, 2 times 6 gives me 12. Now I'm not doing anything to the first equation. I'm keeping that the same. 16x minus 10y equals 10. But because I multiplied this equation here by 2, now something's going to eliminate. Now the question I get in class is, well, where did the 2 come from? Is it always going to be 2? It's not always going to be 2. You're going to have to figure out what number you would need to multiply to make those the same. For example, if instead of a negative 8 here, it was a negative 4, what would I have to multiply by then? Well, I would have to ask myself, 4 times what gives me 16? 4 times 4 gives me 16. So in that situation, it would be a 4. Maybe this one is an 8, but instead of 16 here, this one's just x. Well, then I wouldn't want to multiply this equation because I wouldn't want that number to be bigger. I would want to change this one to look like this. So then if it was x and negative 8x, I'd be multiplying that first equation by 8 so that I have an 8x and a negative 8x. So a lot of this is just going to take some practice and figuring out which equation you want to multiply and by what number. Once you've figured that out, though, and got a system like this, it's going to be the same as what you all were doing before. So I would recommend go ahead, pause the video, see if you can finish solving this system, and then we'll go over it. All right. Well, for this one here, once we've got it set up like this, I see that my x's eliminate, and so I just have negative 22y equals 22. When I divide both sides by negative 22, we're left with y equals negative 1. That's half my answer. Now to get the other half, I'm going to use one of the original equations. I think I'm going to use this one. It says negative 8x minus 6 times negative 1 equals 6. So negative 8x plus 6 equals 6. If I subtract 6 on both sides, that gives me negative 8x equals 0. It's okay. Sometimes people freak out when they get the 0. You're not doing anything wrong. We'll just keep going. If I divide both sides by negative 8, I get x equals 0 divided by negative 8, which is 0. So we get our final answer, 0, negative 1. There's going to be more like this that we practice. Tomorrow is also going to be similar to what we're doing this. Remember I said there's a part 2 to the lesson. I think the most difficult part of this lesson, though, is that idea of figuring out which equation you want to multiply and by what number. So this last one here is going to be for you. I'm going to break it up into 2 parts. So the first question I'm going to ask you is tell me what you would need to do to the system in order to solve. Are you adding the 2 equations? Are you subtracting the equations? Are you multiplying by something like we did in that last problem? Start off just by doing that. All right. So here, if I'm looking at my variables, I want them to be different signs and the same number. I notice for both variables, they're different signs, so I don't have to worry about the signs. For the numbers, here if I look at the smaller number, I'm asking myself, can I multiply 3 by something to get 4? You can't. I mean, you can, but it's going to be like a decimal or a fraction. There's an easier way. Instead of looking at the x's, look at your y's. Can you multiply 3 by something to get 9? Yeah, so let's make the y's eliminate. Here, I'm going to multiply that second equation. What number times 3 is going to give me 9? Well, 3. 3 times 3 gives me 9. If I do that, if I multiply that second equation by 3, I get 9x minus 9y equals 3 times 0, which is 0. That top equation is going to stay the same. So that one's still negative 4x plus 9y equals 5. And now I can see I've got what I want. I've got them the same number and different signs, so I know if I keep going, something's going to eliminate. So I said that was the first part, is just tell me what you're going to do to solve the system. Now that we're all on the same page, go ahead and solve the system. Alrighty, so to solve the system, we're going to have our y's eliminate. Over here, negative 4x plus 9x gives me 5x. And then over here, 5 plus 0 gives me 5. I can solve for x by dividing both sides by 5, and that gives me x equals 1. That's the first part of my answer. The second part, I need to substitute that into one of the equations. I think I'm going to use the second one here. So it's going to say 3 times 1 minus 3y equals 0. That gives me 3 minus 3y equals 0. I can subtract 3 on both sides, and we get negative 3y equals negative 3. And then I can come in and divide both sides to get y equals negative 3 divided by negative 3, which is 1. So we get x equals 1, y equals 1. So my final answer is 1, 1. You could always check that if you want. It's been a second since we've checked. If I were to check, for example, using this first equation, it would say negative 4 times 1. Negative 4 times 1 is just negative 4. Plus 9 times 1. Well, 9 times 1 is just 9. Equals 5. And then negative 4 plus 9 does equal 5. So that helps us know our answer is correct. That was the last example and practice problem for this lesson. Like I said earlier, this is a 2-part lesson, so you may still have some questions about the elimination method that are unanswered at this point. We're going to be looking at some other situations in tomorrow's lesson for part 2. Until then, there are homework questions for you to practice the examples that we did see today. Please reach out to us if you have any questions, but otherwise I will see you guys tomorrow. Thanks, bye.